Hi, this is Carl Leopson at the University of Arizona, and this is a little activity in the visual analysis of single subject research data. We're going to take a look at a graph from a single subject research study, and I'm going to ask you to determine the level within and between phases, the trend within and between phases, the stability within phase, and the data overlap between phases. The study we're going to use is from the Journal of Applied Behavior Analysis, 1998, Prompting Patron Safety Belt Use at a Restaurant by Austin, Elvero, and Olson. Sounds interesting. It is. It's kind of fun. You should read it. Let's take a look at the graph. I had already started doing some work. Let me get rid of some of those lines. The first thing we're going to do is we're going to determine level. Now within phase, that means reporting the mean and the range. Between phase, that means determining whether or not there is an improvement in the level between phases or whether the level is deteriorating between phases. So back in our study, they already have mean lines drawn in here, and if you're looking, if you don't want to calculate the mean yourself and double check them, you can go to the results section. They're going to tell you the mean and the range because that's what's reported. So figure 1 shows that during initial baseline condition, 55% of drivers wore a safety belt as they exited. The range 39 to 83. So it's 55%, 39% to 83%. Between level, or between phases in this study, we can see that the level does change between these two phases and that it's moving in the direction that the researchers had hoped for. So we say that that was improving. Let's take a look at the trend next. We want to determine within a phase whether there is an accelerating, decelerating, zero-accelerating, or flat line, or whether it's a combination, whether it's running in multiple directions. And also whether or not that trend is in a therapeutic or contra-therapeutic direction. Between phases, we simply want to report whether or not there was a change in phase or a change in the trend. So if you remember to calculate trend, we do a split middle analysis. And I know there are 27 data points here, so I'm going to mark out the midpoint. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's take that one out of the mix. Now let's divide each of these into separate sections so that we can determine kind of a rough level for each half of our baseline data. So we know we have 1, 2, 3, 4, 5, 6, 7. We're going to put a line through the 7th data point, so there are 6 on either side here. And 1, 2, 3, 4, 5, 6, 7. So we have 6 on either side there. We're going to go for mid rate. So we're going to work up from up our graph from the bottom. 1, 2, 3, 4, 5, 6, 7. I think it'd be fair to say that it's fair and generous. 1, 2, oops, we're going to go this way from the bottom. 1, 2, 3, 4, 5, 6, 7. So if we draw a line connecting these, you can see we have what looks like in accelerating trend. Trend in the direction that actually they want the data to go anyways. That's not how you want to start your study. And in fact, they probably collected data for a long time in this baseline because their data is so unstable and variable. And because at some points they had an accelerating trend, it just so happens they started their study still with an accelerating trend. They may have just considered the last few data points before they started, but their baseline is so variable that it would be hard to trust this data otherwise. So I think it's reasonable to take a look at the whole baseline in this study. So we would say there was an accelerating and therapeutic trend, which is not what we want. So let's take a look back at our graph. And the next thing we're going to do is analyze the stability. So we already have our trend lines up, so we can draw a confidence interval or a stability interval around our trend line. And first we find the mean, which is 55. So that means 10% on either side gives us our 20% confidence interval. So just about at about 45, let's say, start our line at 50. And 40, maybe a little below. Give them a break on that one. And for stability, we want to determine the data points within the 80-20 stability envelope. So how stable is that data? We've got 1, 2, I'll count this one, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have about 11 data points divided by times 100, about 41% or 40.7%. That's nowhere near the 80%. So we would say it is variable. We can't report on stability between phases. It's not something we have to worry about. Let's go back and take a look at data overlap as the last element. And this is only reported between phases. All right. So what we do to figure out percentage of non-overlapping data is draw a range around our baseline data, or the data for the phase prior to the phase that we're looking at. And the suggestion would be that if this intervention was really strong, all of the data should fall outside of, above, in this case, the range of the baseline data. Instead, all of this data falls within. So we end up with the number of data points that fall outside of the range, which is 0, divided by the number of data points in the phase, which was, doesn't really matter, but it's 5. So we've got a 0. And I'm sorry, that's darkened. Let me change that. It won't be that way on yours. Shading, no fill. Okay. So we're going to say, oops, data overlap. Nope, hold on here. That should be darkened. Excuse me, guys. Been a long day. All right. Let me get that one too. So here, between the first two phases, that is a 0%. What percent of the non-overlapping data? So there is no non-overlapping data. All of it is overlapping. In the comments section, I'd like you to just add any comments. I might say, wouldn't have started my study. Whatever you think you find interesting about the phase that you've analyzed. So get the worksheet. I'll post the study. I've been doing my analysis and creating these videos using Preview on the Mac. It's pretty good for notating on a PDF. If you have PDF Fill on a Windows machine, you could do pretty much the same thing, I think. I don't know what other programs they have on a Windows machine so that you could annotate on these PDFs. On your computer, you certainly can print out the study. It's a short study. You can print out the study and do your calculations on the graph and draw on it with a pencil. All right? Post it when you're done. Happy analysis.